Hey guys, so today we're going to do an introduction to angles. Now that we work with angles and triangles, we're going to place the angle on the XY plane and rotate it around to form different angle measures. So we call from geometry and from based off of what we learned this year, an angle is formed when you've got two rays, right? And the angle, let's call this angle A. Or we could say the measure of this angle is measured by theta. So an angle is formed by two rays. Depending on how far the rays open, a large angle or a small angle can be formed. So instead of looking at an angle in a triangle, now we're going to place this angle on the XY plane. So when we talk about an angle in standard position, a standard position angle is an angle with the vertex at the origin and one ray that forms the angle, which we call the initial side, is on the positive x-axis. And then we have another ray that forms the angle, which we call the terminal side. So here is another ray, and so here's 0 degrees, and if I start turning it and rotating it, it'll become 10 degrees, 30 degrees, 45 degrees, and then on the y-axis is 90 degrees, and I can keep turning it, right? So then I know that once I turn 180 degrees, that is a straight angle, and then plus another 90 degrees, so each quadrant represents 90 degrees. That's 270. And then one full circle, that would be 360 degrees, will be one revolution. If I spin it, this will be 360 degrees. So this side that moves is what we call the terminal side, and depending on where the terminal side ends, in quadrant 1, quadrant 2, quadrant 3, or quadrant 4, we have an acute angle, a right angle, an obtuse angle, and a straight angle, right? So we call this the terminal side. The side that doesn't move, that is on the positive x-axis, we call the initial side of my angle. And in standard position, the initial side is always on a positive x-axis. And the side that turns to form my angle is what we call the terminal side. Think of the word terminate, where it ends, right? The terminal side is where my angle ends. And depending on where the terminal side ends, an angle, theta, is formed. And the measure of that angle can be measured in degrees. And so, depending on which quadrant this terminal side stops to form my angle could be acute if it's in quadrant 1, could be obtuse if it's in quadrant 2, past 90 degrees, and then it could also be in quadrant 3 or quadrant 4. So an angle can be formed in any of these quadrants, and if an angle happens to land on the x or y axis instead of being in a specific quadrant, we say that that angle is a quadrantal because it's in one of the axes. So a 90-degree angle is what we call a quadrantal angle. It's not in any of the quadrants. And a 180-degree angle is also called a quadrantal because it's not in any of the quadrants. So when we have an angle that we rotate counterclockwise from the positive x-axis, we call those positive angles. And usually, when we talk about an angle, we always spin it counterclockwise from the positive x-axis. There's also negative angles, and the only difference is that for negative angles, we rotate it clockwise from the positive x-axis. So for example, in example 1, if we want to draw the following angles in standard position, so let's start with standard position, my initial side is on the positive x-axis. And then my angle is formed by taking my terminal side and just rotating it. Because it's positive, in this case positive 210 degrees, I'm going to rotate it counterclockwise. So this is 90, this is 180, and 180 plus 30 is going to give me 210. So about 30 degrees more from 180 degrees. Here it is. And the angle that is formed from here to here is 210 degrees. Now, if I want to draw negative 70 degrees, again, we're going to start the same way in standard position with the initial side on the positive x-axis. And then because I'm going negative 70 degrees, we're going to rotate clockwise. So I'm going to go the other way. Here's my terminal side. I'm going to spin this way now, going backwards, negative. Okay, so negative 45 degrees will be right here. That's half of 90. So 60 degrees would be around here. 70 degrees would be roughly over here. Negative 70 degrees. And that is formed by taking my terminal side and turning it clockwise, negative 70 degrees. And then one last one, well, what if we want to go 270 degrees? Let's take a look at what that looks like. So, standard position, initial side on the positive x-axis. Now I'm going to take my terminal side, and because it's a positive angle, I'm going to rotate counterclockwise. So 45 degrees, 90, right? 90 plus another 45, and then plus another 45, 180. 180 plus 90, 270. And we know that one full circle, one full rotation, is 360 degrees, is a full circle. So 360 degrees lands me here. I'm going to keep going. So 360, 10 degrees more is going to be right here. It's a very small angle, 10 degrees more. And to indicate that this is not just 10 degrees, I'm going to draw this arrow. I'm going to rotate 360 plus a little more, 370 degrees. Okay, so summary, positive angles, you rotate counterclockwise, and negative angles, you rotate clockwise. So let's do the reverse. Instead of giving you an angle and asking you to sketch it, I'm going to do the reverse and ask you to find the angle given a diagram. So in example 2, we want to identify the measure of each angle in degrees. So in this case, we've got the red is the angle that we're trying to identify, and the green measurements are some hints to help us identify the angle that we need. So I know that from here to here is 90 degrees, and if that little part is 50, well then I know that this angle must be 40 degrees. Okay, and then same thing here. I know that to go from here to here, that's 180, and then 90 more will give me 270, and then 40 degrees more as shown by that little green measurement. So the measure of this angle is going to be 270. That would be 390s plus 40 degrees more. That's going to be 310 degrees. Now notice that the first two angles are rotated counterclockwise, so I know that they're both positive. But that last one, I'm going clockwise, so I'm going the other way. So my answer is going to be negative. It's going to be a negative angle. And I know that from here to here forms a straight angle, so that is 180 degrees. And I have to go a little bit more, okay? And since this part is 80 degrees, and one of the quadrants forms a 90-degree angle, this little piece must be 10 degrees. So we went negative 180 degrees, and then we added another negative 10 degrees, or subtracted 10 more degrees, and now we're at negative 190 degrees. That is the measure of that angle going clockwise.